Here's more practice in using inverse to solve. We're going to solve 5 cosecant squared of x minus cosecant of x minus 6 equals 0. So first we can factor. 5 cosecant x, and a plus 1 here, and a minus 6. So if you use the zero product property, we have cosecant of x equals 6/5, and cosecant of x equals -1. Now using the reciprocal, we have sine of x equals 5/6, and sine of x equals -1. So sine is -1 here at 3 pi over 2. So x equals 3 pi over 2 plus 2n pi. Sine of x is positive, so y is positive in quadrants 1 and quadrants 2. And then 5/6, we don't know that exact number from the unit circle, so we're going to have to use arc sine. So we can use x equals arc sine of 5/6 plus 2n pi, and that gets us our quadrant 1 answer. Now when sine of x is less than 1, we're going to have two answers, right? And we already talked about that. We have an answer in quadrant 1 and an answer in quadrant 2. But we do need to remember that arc sine, we have to restrict to only quadrants 1 and 4. And so that is from negative pi over 2 to positive pi over 2, right? But more than anything, just remembering that arc sine, we can only get answers in these two quadrants here. So we do need the answer because sine is still positive in quadrant 2, and we can't really get there using arc sine, so we're going to have to alter it just a little bit. So we did find an answer here, our arc sine of 5/6 in quadrant 1. And so what I'm going to do is we haven't used an answer here in quadrant 4, which we could use. So I'm going to change it. I'm going to put the answer down here in quadrant 4, and we do that by changing the sign. So essentially, I'm saying sine of x is -5/6, right? So then I would write x equals arc sine of -5/6. Okay, so that just gets me into this fourth quadrant here. Now, again, we want our answer to be positive, right? That's the answer, positive 5/6. And so to do that, what we have to do is to add pi in order for us to be in quadrant 2. So arc sine of -5/6 plus pi. Now we have our answer here, right? So we have the answers of when sine of x is 5/6 in quadrant 1 and sine of x is 5/6 in quadrant 2. And then the last piece is being able to add the repeating, right, that it repeats over and over again. So then we would add 2n pi, and so that would get us all of our solutions for this example. So you go ahead and try this example. Solve 9 cosecant squared of x plus 9 cosecant of x equals 4. So if you tried this out, this would factor to 3 cosecant of x minus 1 and 3 cosecant of x plus 4, right? You set it equal to 0 first. So then we would find cosecant of x equals positive 1/3, cosecant of x equals -4/3. Then we do the reciprocal. Sine of x is 3, and sine of x equals -3/4. Now just so with that we remember, so we have sine of x equals 3, that is outside of the range of -1 to 1, therefore there are no solutions for this case. But we do have sine of x equals -3/4, and so sine is negative in quadrants 3 and quadrants 4. So we can use the arc sine to get our answer in quadrant 4. X equals arc sine of -3/4 plus 2n pi. And then we also need our answer here in quadrant 3. So just like in the last problem, what we're going to do is we're going to change it. So we're going to get a positive y value instead. So we're going to use arc sine of +3/4. So here it is in quadrant 1. Then, but our true answer that we want is in quadrant 3. So from here, the arc sine of 3/4, we add pi, and now we're here in quadrant 3. So now we have all solutions of when sine of x, sorry, is negative 3/4 here. And then we just have to add the repeating of 2 and pi.